In this video, we will generate the dataset of the Euler's cosine formula and its Taylor series expansion. We begin with the values of V. So data validation, list of items from 0.5 to 2. So we copy this and 0.5 to 2. We can start with 0.5. Likewise, W. So data validation, list of items 2 to 5. So 2, 3, 4, and 5. And we can start with 2. This is for the Euler's formula. We copy this, and for the expansion, we use the same, except that we will change the color to red. Now we continue with the Euler's cosine formula, which is complex. Start with the complex. That's minus Vx minus V times x, comma, plus Wx, so W times x. And because this is the array, so we use array formula. Array formula. So we have the array formula of the complex. We continue. This is Euler's number, which is e to the x. So we now use the im exponent. That's im exponent. That's the Euler's number. Another. But we're interested only the real part. So again, we use im real. So that's the im real. We use the im real function. So this is the Euler's cosine formula. Next, the Taylor series expansion of the Euler's cosine formula, which is the summation of a times x to the power n, where the value of n is from 0 to infinity. Set 27 is good enough, and the coefficient a is, we begin with the complex, the innermost, so complex minus b, comma, w. And because this is an array formula, so we use array formula. We use array formula. Array formula. And this is raised to the power, n. So to raise it to the power n, so im power. So this will be im power. We use im power. Im power. Raised to the power n. So where n is this values. But we're interested only in the real part, so we use the im real. So this is im real. Im real. So this is the real part. And finally, we divide by factorial n. So this is m real divided by factorial of n. So this is factorial. Factorial of n. Now we can complete the Taylor series expansion. Array formula, series sum of the x values raised to the power n, where n starts from 0, incremented by 1, and the coefficient will be this range. And now we'll chart this. So insert chart. And we use scatter chart. We don't need the title here. And the setup, use column as label. And customize the series, show the trend line. The type, polynomial. The degree, 10. For the label, use the equation. And for the legend, we don't need, just auto. So here's the polynomial and the trend line. Begin with we change the value of w to 3. We can also change the value of w, the Taylor series expansion w to 3. Now they're the same. Change this to 4. We're increasing the frequency. We can change this also to 4. Change this to 5. Increase this to 5. Suppose I change this to 1. I'll change this to 1. And the same, I'll start from 2. I'll also change this to 2. Change the cosine to 3, the frequency of cosine. The Taylor expansion also to 3. Change the blue one to 4. And the red one also should follow, also 4. Change the blue one to 5. And this also 5. Change this to 2. So we can also change this to 2. And the same. Starting from w equals 2. We can change the red one to 2. Change the blue one to 3. We can also change the red one to 3. Change the blue to 4. You can also change this to 4. Increase the frequency to 5. We can also change this to 5. This completes the use of the series sum and Taylor series expansion, the functions complex, IMEXP, IMPOWER, IMREAL, to show the Euler's cosine formula.